Good morning, one and all. My name is Andhur Gaurav from Vignan Sunarla. Today we'll discuss the topic called as the graphical convolution. Graphical convolution. Generally, the convolution of the two signals will be given as y of t is equal to x of t, convolution with the h of t. Generally, we will employ these two signals as x of t as the input signal and h of t will be the impulse response of the system. Therefore, the graphical convolution formula as y of t is equal to minus infinity to infinity, the corresponding x of tau and h of t minus tau d tau. Or else we can also use the another expression as minus infinity to infinity, x of t minus tau, h of tau. Anything we can use it. Now, if we consider a simple example like this, that is x of t, which is being defined from minus 3 to plus 3 with the amplitude as 1, and the h of t will be defined as from 0 to 3 with the amplitude as 2. These are been with respect to t. This is also with respect to t. Okay? That is x of t is be defined from minus 3 to plus 3 with the amplitude as 1. I'm writing here it is, that is x of t will be defined as 1 for minus 3 less than or equal to t less than or equal to 3. And it is equal to 0 otherwise. Similarly, h of t will be defined as 2 for 0 less than or equal to t less than or equal to 3 and 0 otherwise. Then the correspondingly the two signals, when we want to convolute the two signals, first signal will be written in terms of tau if we use this formula, and the second signal will be written in terms of h of t minus tau. First the x of t will be written in terms of x of tau. That means t variable will be changed to the tau. Therefore, the graph will appears like this. From minus 3 to plus 3, we'll have the amplitude as 1, which varies with respect to the tau. Similarly, h of tau, that means the first signal we have got it, x of tau, which varies with respect to tau, which is being defined from minus 3 to plus 3 as the amplitude as 1. Similarly, when we use the h of tau, that is h of t minus tau, we should get it. For getting the h of t minus tau, first convert this h of tau towards the negative like this, h of minus tau with respect to tau. First draw the h of tau. First we will draw the h of tau. H of tau means h of t will be replaced with the tau. That's why it will be defined from 0 to 3 like this. And the next step as h of minus tau, then whatever the contents which are being present in the positive will be shifted to the negative. That's why 0 to minus 3 it will be the amplitude as 2, which is the amplitude as 2, that is h of minus tau, and the next h of t minus tau, simply adding the t units to the h of minus tau. As it is being defined from minus 3 to 0, add the t units. That 0 will be added with the t units. That's why it will go to the t point. And minus 3 will be added to the t units. That's why it will go to the t minus 3. Therefore, the graph will appears like this. Between the t to minus 3, t minus 3, its amplitude as 2, like that. Therefore, it's been with respect to tau. This is also with respect to tau. This is the graph for h of t minus tau. Okay? Now our main concentration is we need to use this x of tau and h of t minus tau in a one particular non-overlapping time interval. For that, let us consider like this. The first signal will be taken from x of tau. Now, the first signal is x of tau. Therefore, they take that x of tau from minus 3 to plus 3. minus 3 to plus 3 with the amplitude as 1. Now our intention is to, we need to draw these two signals on a one particular common axis of tau without any overlapping. As the first signal will be defined from minus 3 to plus 3, therefore the second signal h of t minus tau should not be present in this particular interval, and it should be before this particular interval. That's why I am considering this particular t as very less than minus 3, like this, very less than minus 3, that is before the minus 3 to plus 3, and the t minus 3 is also before this particular t. That means there is no overlapping of these two signals at this case. As there was no overlapping, the first point is that the first signal will be defined from minus 3 to plus 3, another signal will be defined for from my t minus 3 to t, where the t will be very less than, minus 3. That is the case of the case 1, as there was no overlapping. If we observe our y of t expression, y of t is equal to minus infinity to infinity x of tau h of t minus tau d tau. Therefore this particular product is, what is this particular product? We will observe there was no common region between those two. Therefore this product will be said to be 0. Therefore obviously the integration will be said to be called as 0. This is the case for only the t less than minus 3. If the t is being moved to the different sections, we'll get an overlapping region, then we'll get a particular product to this particular product, then we'll perform the integration, then we'll get a finite value for the y of t. That is the step, that is the process of doing the graphical convolution. The first case, as for the t less than minus 3 we are taking, where there was no overlapping, no product, therefore the output will be 0. Okay, next the second case has been like coming to the case 2. The first case has t less than minus 3, therefore the shift this particular t to the next position from minus 3 to 0, for example. Therefore the graph will appears like this. The first signal is same as this, that's from minus 3 to plus 3 with the amplitude as 1. Therefore the second signal will be shifted to, this is the t minus 3, this one, with the amplitude as 2. This is x of tau, h of t minus tau with respect to tau. Therefore when we observe this y of t, this was the case 2, as the t will be between the minus 3 to 0. That's minus 3 less than or equal to t less than or equal to 0. Therefore our y of t generalized as minus infinity to infinity x of tau h of t minus tau d tau. Therefore the common region what we'll have here is, this is the common region, this was a common region. Therefore the common interval is from minus 3 to t, that's been given as minus 3 to t. What is the value of x of tau? Its amplitude as 1. H of t minus tau, its amplitude as 2, and d tau. As 2 is constant, keep it outside. 1 integration as tau, upper limit minus 3 and the lower limit, upper limit is t, lower limit is minus 3. Therefore 2 into t minus 3, that is equal to 2 into t plus 3 is our output of y of t. For the case of t will be from minus 3 to 0. In the case 3, let the t will be shifted to this particular position, that is 0 less than or equal to t less than 3, like this. That is the second. Third case, minus 3 to plus 3, and this t will be shifted to here, t. Then the t minus 3 will be between the minus 3 to 0. Here the amplitude as 1, here the amplitude as 2. Therefore our y of t is equal to minus infinity to infinity x of tau h of t minus tau d tau, which is equal to Now the common interval when we observe for the case of 0 to 3 is this particular one. The common interval is this one. Therefore the limits will be from t minus 3 to t. Limits will be from t minus 3 to t. Then the amplitude of x of tau is 1. This h of t minus tau is 2, d tau. This 2 will be kept outside. Therefore, one integration will be the tau with the limits t and t minus 3. Therefore, substitute the limits t into 2 into t minus 3. That's this and this gets cancelled. It is the 6 will be your answer. That is the case of the third case. In the case 4, as let the t will be shifted to the next position, that's greater than 3, but it must be the less than 6 to maintain this t minus 3 in this particular interval from 0 to 3. That's when we draw the picture like this from minus 3 to plus 3. First take this t beyond this particular 3 and in between the 6. Therefore this was the interval. And the t minus 3 will be present between the 0 to 3. T minus 3 will be from 0 to 3. And as well as this particular t will be between the 3 to 6. That is the case of 3 less than or equal to t less than 6. T will be between 3 to 6 and t minus 3 between the 0 to 3. Therefore, the case of y of t is equal to minus infinity to infinity, x of tau, h of t minus tau, and d tau. Therefore, the limits, the common region what we have is been from t minus 3 to t. T minus 3 to t. The amplitudes as 1 and 2 here. Therefore, 2 will be kept outside. Integration as tau with the limits t and t minus 3. 2 into 3 minus t minus 3. That is equal to 6 minus 2t minus again 6. That is 12 minus 2t. There minus of minus plus, that's why 12 minus 2t. Sorry. 12 minus 2t is your answer. That is the case of the fourth. Next one. The next case is from take this t will be greater than 6 and the t minus 3 will also be greater than 3. That is the case as in the case 5 as 3 greater than 6. The t will be simply the greater than or equal to 6. That's the first signal will as it is from minus 3 to plus 3. And the second signal, the second signal will be like this. This is t minus 3. This is greater than 6. This amplitude as 1, this amplitude as 2. We'll observe that as t will be greater than the corresponding 6, greater than 6, then obviously the t minus 3 will be between the 3 to 6. Therefore, our y of t is equal to minus infinity to infinity x of tau, h of t minus tau, d tau. We'll observe that the two graphs are not overlapped. Therefore, no common region. Therefore, product will be 0. Therefore, our y of t will be equal to 0. Y of t will be equal to 0 the case. We'll observe that we'll observe the 6 cases of this particular one. We have got the cases as been like this. For the y of t is equal to 0 for t less than minus 3, and between minus 3 to 0 it is 2t minus 6, and between the 0 to 3 it is been 6, and between 3 to 6 it is the 12t minus 2t, and for t greater than or equal to 6 it is been 0. Now when we plot this y of t graph like this, we'll observe in the first case of this one, for t less than minus 3 it is values as 0, and between for t greater than 6 its also values has been 0. Therefore this has minus 2, minus 1, 0, 1, 2, 3, 4 and 5. Therefore when we put the minus 2 here, that is this case, when t is equal to minus 2, 2 into minus 2, minus 6, that is being given as the t value as minus 2, therefore 6 minus 6, that is 2 into minus 2, minus 6, that is equal to, correspondingly it's been as the, now take the cases of the t is equal to minus 2. When we put the t is equal to minus 2 here, then that minus 2 into minus 2 is minus 4 plus 6. That means we'll get the 2 here. The amplitude as 2 for minus 2. When we put the minus 1, that minus 2 plus 6. Minus 2 plus 6 means 4. The 4 amplitude for minus 1. Next for 0, it will be 6. When we put here also 0, it will be the 6. Therefore at 0 it will be the 6 amplitude. Next for 1 also 6. For 2 also 6. Next for 3 also 6. For 4, when we substitute here for 12 minus 8, it will be 4 like this. Next when we put the 5, 12 minus 10, that will be 2. Next when we put the 6, when we put 6 it will be the 0 directly. When we combine these all values like this, that will be the graph of our y of t. This is the y of t, convolution output, that is x of t convolution with the h of t. Okay, that's how we'll perform the convolution.